Good morning, ladies and gentlemen. So before we're gonna start our talking about mathematics, so let me first introduce myself. So I am Miss Jean Claire Carvajal Chome, your speaker for today. So as you noticed, we're living in the world full of shapes. So even in the food that we eat, it contains a shape that what we call polygons. So the landmarks that we see and the other things such as our room. Then today I'm gonna ask you, did you ever wondering why it is named like that, and how we're gonna name a shape, or how we're gonna name a polygon? So today we're gonna discuss the introduction of the polygon. So we will define, identify, and illustrate the different kinds of polygons according to the number of sides. So we will also differentiate convex to non-convex with what we call concave polygon. So let's also identify the parts of the polygon. So let's explore the world of polygons. So as we noticed, here's the definition of the polygon. So a polygon is a closed figure formed by three or more segments called sides. So example of that is this one. So each of sides intersect exactly to another side once at endpoint. So also there's two sides with a common endpoint are called collinear. So let's see. So this is the example. That's the our endpoint. I put a red marking. So the one that connected them is what we call endpoint. So here's the example of a collinear. Did you see that I put a red marker here? So this is our first side. So from this point going to this point, then this is our second side. So from this endpoint going to their endpoint, and they meet here at the center of their endpoint. So each of the line segment has a common endpoint. So that's why it is not a polygon, or what we call, because it is a collinear. So as you notice, I put a red marking to see that it's really have a common endpoint. Each of the side or each of the face has a common endpoint. So that's why it is not a polygon. So next. So each line segment is called the side of the polygon, and each endpoint where the sides meet is called vertex of the polygon. So this is our side, this one, the blue marking, and our red marking here is our vertex. So next is the classification of the polygons. So in this column you see the number of sides. The second column is the name of the polygons, and the third column is the codes of the polygon. So we have number of sides. We have 3. So we have 3 number of sides. It is what we call the triangle. So its code is tri, from the word this one. That's our code. Tri means 3, right? So it is called triangle. So we have the number of sides that we have is 4. So 4. This is what we see. 4. So the code that what we use is quad. So that's why it's called quadrilateral. So if the number of sides is 5, so did you see 5? So our code is penta. So penta means 5. So that's why we called pentagon. So if the number is of the side is 6, so we have hexa. The code of that is hexa. And then that what we have is the hexagon. So if the number of sides is 7, so we have the hepta. And that's what we called heptagon. Then we have the number of 8 sides. So we have octa. That we have octagon. So octa means 8, right? So that's why it calls octagon. Then if the number of the sides contains 9, so it's called nonagon. From the word nona means gone. Means 9. Sorry. So if the number of sides is 10, it have 10 sides. So that's what we call decagon. So deca means 10. So our code here is deca because deca means 10. So ma'am, what if the number of the sides is 11? What we're gonna call that? So from the word 11, we have the code uno plus deca. So uno means 1. So I said earlier that 10, our code of 10 is deca. So 11. So deca plus 1. So uno plus 1. So we have that 11. So it's called andecagon. So ma'am, what if we have 12 sides? So it's what we call dodecagon. From the word duo means 2 and deca means 10. So we have 12. So it calls dodecagon. So if we're going to name 13 and above sides, we gonna input n. So it's what we call the n-gon. So next, parts of the polygon and the names of the polygon. So I said earlier the codes of the polygon. So this is the face of the triangle. So it has 3 sides. So let's count. 1, 2, 3. So our endpoint is 1, 2, 3. So it's called triangle. From the word tri. So it has 3 sides. So it's triangle. Next, we have the quadrilateral. So let's count the side. 1, 2, 3, 4. And the endpoint is 1, 2, 3, 4. So that is quadrilateral. Next is pentagon that have 5 sides. So 1, 2, 3, 4, 5. So that is pentagon. Next is what we have hexagon. So hexagon has 6 sides. So let's count if it is a hexagon. So 1, 2, 3, 4, 5, 6. So it is a hexagon because it has 6 sides. So next is the heptagon. So heptagon has 7 sides. So let's check it. So 1, 2, 3, 4, 5, 6, 7. So it has 7 sides. So next is the octagon. So octagon contain 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. Next is the nonagon. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it contains 9 sides. So let's now proceed to the decagon. So decagon means 10. It has 10 sides. So deca means 10. So it contains 10 sides. So let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a decagon. So next we have the undecagon. So and then the dodecagon that contains 12 sides. So we have our figure here, the pentagon. So let's check if it is a pentagon. Then it contains 5 sides. So let's check if it's really a pentagon. So we have 1, 2, 3, 4, 5. So it is a pentagon. So let's count, or let's see the vertices. So we have vertex A, B, C, D, and E. So let's check if it is true. So what we have is our vertices. It's like I said earlier, is that what we have vertices A, B, C, D, and E. So ma'am, can we name it as E, D, C, B, A? So yes, we can call it the vertices A, E, D, C, B, A. We can call that in that way because it should be so it should be named as consecutively. Dapat magkakasunod. So it can be clockwise. You can read it clockwise or counterclockwise. So basta it is consecutively naming, so it is okay. So you can call it vertices A, B, C, D, E, or E, D, C, B, E. So another parts of the polygon is that the angles. So let's find the angle here. So we have angle A, angle B, angle C, angle D, and angle E. So again, we can namely it consecutively, so you can make it counterclockwise or clockwise. So let's proceed to the side. So as you can see here, we have the highlighted blue. The line here is highlighted blue. So we have the side AB, then BC, CD, DE, and EA. So it should be paired because we're talking about the side. Okay. So next we have the consecutive vertices. So we see if we say consecutive, so it should be magkakasunod, right? So we have the vertex A and B. So B and C kasi it is magkakasunod, right? So it is consecutive. So I put A and B and C only to example, but remember there's a lot of consecutive vertices here in pentagon. So we have the CD, DE, and EA. So next is we have the consecutive angle. So again, if we say consecutive angle, it should be magkakasunod, right? So we have next is the consecutive side. So no, we have the angle first. We have the angle A, angle B, angle C, angle D, and angle E. So next is the we have the consecutive side. So our consecutive sides, as I say earlier, it is highlighted by blue. Okay, we have here the side AB, consecutive, so magkakasunod. We have the side BC, side CD, and side DE, and side EA. So in the diagonal, you see here, we have our diagonal AC, side A. Next is the AD. Next is the BE, the BD, and the CE. That's our diagonal part of our polygon. So let's now see if our example of convex or concave polygon. So let's now identify. So this is our convex example. So let's check. So a polygon is convex if no line that contains. So again, a polygon is convex if no line that contains a side of the polygon contains a point in the interior of the polygon. So next is a polygon is convex if no diagonal is in the interior or exterior of the polygon. So first, let's check if it contains a point in the interior of the polygon. So we have the line here. So let's see. Okay, it's clearly see that it is clearly see that there is no line that contains a side of the polygon contains a point in the interior of a polygon. So okay, so you can see buo siya. So let's check here. Okay, as you can see this one, there's a point in the interior of the polygon. So this one point and this one point. So let's have next example of the polygon is convex if no diagonal it is in the exterior of the polygon. So as you can see, nasa loob lahat ng line is walang nakalabas or there's no diagonal in the exterior of the polygon. So now let's check here. So that's our point, 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 and point. So as you can see here, there's a line or there's a lot of diagonal in the exterior of the polygon. So may mga line na nasa labas. So you can see this one. Okay, so next is the regular polygon. So a regular polygon is equilateral if all the sides have equal length. So it have an equal length. So take note of that. So next is that a polygon is equiangular with all the angles have an equal measure. So next is the regular polygon is both equilateral and equiangular. So we have here is the regular polygon. So a regular polygon contains what we call have the marking right here. So if the polygon or if the figure indicated a marking, so it can be considered as it has a measurement, so should be a 90 degree. So we can see here, so a polygon, a regular pentagon contains 108 degree of each of the side or each of the vertices. So we have here 108, 108, 108, and 108. So we have the equilateral triangle containing 60 degree of each of the sides, I mean each of the vertices. Next is that we have the square. So a square is the perfect regular polygon. So all the sides are equal. So it's have a 90 degree, and square is considered as one of the special figure of the regular polygons. So this one also the regular hexagon. So that's what we name our polygon. So again, let's recall. So we should remember that a polygon is a closed plane figure formed by 3 or more segments called sides. So it is also each sides intersects exactly to another side once meet at the end point. So no two sides with a common end point, or that's what we call the collinear. So a A regular polygon is considered as an equilateral and then equiangular. So, a regular polygon contains both the equilateral and the equiangular kinds of polygons. So, this is all. So, thank you and goodbye.
Thank you.